Hello, this presentation is model systems. It's a coordinate graphing of systems of measurement. There are two systems of measurement that will be graphed. The systems of measurement that we're dealing with is metric and degree. They represent distance, metric represents distance, and degree represents angle. In mathematics, particularly graph theory and computer science, a directed acyclical graph, DAG, is a directed graph with no directed cycles. That is, it consists of verticals and edges, also called arcs, with each edge directed from one vertex to another, such that following those directions will never form a closed loop. A directed graph is a DAG, if only if it can be topographically ordered by arranging the vertices as a linear ordering that is consistent with all edge directions. Wikipedia 2025. You can see on the right, these are nodes. A causes B and C causes D, or A, B, and C causes D, and A, B, C, and D causes E. A causes E. In this case, regarding the graph that I will present following, you have the causation of the nodes A origin at 0.00 or XY intersect. It's a perpendicular intersect of two lines at a 90-degree angle. B and C can represent the angle measurement and distance measurement, or axis X, which is the angle, and axis Y, which is the distance. D can represent the hypotenuse, 7, 1, or hypotenuse in general, or the three hypotenuses that are derived from point 0, the intersect. And finally, E is the probabilistic correlation of the nodes that represent specific numbers that have been graphed onto the coordinate graph. The two systems of measurement combined reveal a probabilistic correlation at 0.79. Here we have three hypotenuse. Hypotenuse 1, 2, and 3. Hypotenuse 3 represents the third line out. Second line out is 14.14, and the first hypotenuse is 7.07, also represented as 7.1. If you round up, then it becomes 7.1, 14 point, and 21.21. What you then have is the hypotenuse divided by the angle measurements 90, 180, and 270 here. And they create a proportional relationship of 0.079. 0.078567420131839. This is rounded up to 0.79. On this graph, if you round this next graph is the actual graph and where you see the hypotenuse. So you see the first hypotenuse here at 7.1. This line actually represents the second hypotenuse at 14.14, and this line represents the third hypotenuse at 21.21. These hypotenuses are from the Pythagorean theorem, a squared plus b squared equals c squared. This is 5 and 5, so 5 squared plus 5 squared equals c squared, 50, and it's then 50, it becomes 7.1. Here you have 90, 180, and 270 rather than 360. This is the difference between these two. And this is where you have the graph curving. because the correlation actually occurs at 270, not at 360. This line, this hypotenuse, and this arc basically are measured actually the same, but because it's curved, you cannot give it a metric distance. This graph represents the proportionality between 90 basically and 5. So 90 and 5 are actually proportional. And you can see the breakdown down to a 0.1, 0.2, 0.3. And if you divide 90 by 18 and then by 5, you basically can break this down proportionally using these numbers. Again, you see 90 here and 5 here. They actually represent 1, 2, and 3. And here is it 1, 2, and 3 point. 15 is 3. 2 is 10, and 1 is 5. Actually, it's a 5 measurement, but it counts as 1, and this is a radius. They're both radius. So here's a 5 at radius 1, radius 2, radius 3, and that's basically how you can coordinate the graph using a Cartesian understanding of how these graphs are. Here is 1.1. 0, 1.1, but these overlap. The angles basically graph onto the x-axis at 90, 180, and 360, and that is the units that they use for degree. In this graph, you see 1 and 1 up here, and you see 0.1 and 0.1 down here. That's an x and y value, and this is an x and y value, both. And there's proportionality between this this point, this box here, and this box down here. That you have basically proportionality between this size and this size, 0.1. And this actual proportionality can go down to 0.01 and 0.01 xy, and then 0.001, 0.001 xy. In this graph, you have the coordinates of 1 and 1, and you have the coordinates of 2 and 2. Again, it's framed in a Cartesian graphic arrangement, the linear distance of measurement. And here you have the hypotenuse again at 1. And as you go down into 0.75, 0.375, so on, these are points. Actually, these are halves from 3. So what I have done here is taken these two numbers, 2.5 and 3, and basically scaled them down by half. So 3 and 15. The slide is jumping. But you can see how it diminishes from 3 and 2.5. And this continues to go down by half, by half, by half, by half, by half, by half, till you get to 0.1 and 0.1. And here you get 0.1, 0.1, and 0.1 here for 0. This is actually the inner itsy bitsy little corner of the graph in a sort of a quantum arrangement of x and y points. The point that I would like to make is that 0 is true. And when you get to 0.00001, the one is basically becomes kind of like quantum dust. Here you have the continued diminishing down to 0.01 here. And here you see the red. Here is basically this block here. This block in here is this block here. And this is still the y and the x-axis. The end.